Hi, I'm Sean Gannon, and this is Minute Math, and we have a geometry critical thinking question here. We gotta find x. Our figure here is a large right triangle with lots of other right triangles inside of it. We have some lengths given to us. The length of AD is 25, and the length of FE is a 12, and we need to find the length of AC. So pause this video, see if you can remember some stuff from geometry, or really can solve this problem. Find x any way that you can. All right, so pause this video, see if you can do it. But as always, I'm gonna show you a way to solve this problem. All right, first thing first here is, I see we have a lot of right triangles here, so I know I'm gonna need some angle measurements, maybe to find some things that are similar, get some proportions going on here to get to x. So I'm gonna give some angle measurements as a value. So the first one here, let's call CAD alpha. So whatever that angle measurement is, let's call it alpha. Now, because triangle AEF is a right triangle, notice right here, right angle here, so this must be a right angle here, we know that alpha and this angle right here must be complementary. They must add to 90 degrees, because this is already 90 degrees. So if that's the case, AFE, let's call beta. So I'm saying here that angle FAE is equal to our alpha, and angle AFE is equal to beta. Well, with that information, I'm gonna see, well, how many more alphas and betas I can put in there. And I won't necessarily show them all right here, we can see it visually here. But notice again, complementary angles. We have a right angle here of AFD, and this is beta, so this angle right here must be alpha, EFD. Similarly, then if this is alpha, this angle here must be beta. Again, right angle here overall, so this whole thing is a right angle down here, meaning this is our alpha. With that being said, since this is a right angle, this is a right angle, this is beta. And if that's beta on the right angle complementary, this must be alpha. And lastly, this is alpha, right angle, we have a beta. So very quickly, we can show that a lot of different angles within this figure here are congruent. They're the same measurement here. So this is gonna help us really determine some similarity of the triangles. And notice really any triangle that you see is similar. They all have angle measurements of alpha, beta, and 90 degrees. Alpha, beta, 90, alpha, beta, 90, alpha, beta, 90. Meaning that every triangle that you see that you can create an alpha, beta, 90 by the angle theorem, you can say that these triangles are similar, meaning that their side lengths are proportionate. All right, so where can we go from here? Let's look at triangle AFD. Triangle AFD. Notice that we have an altitude here of FE, and that altitude is a 12. And there's a geometric mean theorem that we can apply. It states this, that N over an H equals H over an M, okay? And H is our height here, and then N and M are opposite of the altitude, kind of going into it here, these two parts. This being N, this one being M. So let's go apply what we see and put in values we know and see what we get. So if H is our 12, we have N over 12 equals a 12 over an M. Meaning to us here that, well, 12 times 12 is 144, that N times an M, the two lengths here, is equal to 144. We also have a second equation here. Again, like I said, this is N and M right there. That if we add them together, we get a length of 25. So an N plus an M is equal to a 25. And so now we want to ask ourselves the question, what two numbers multiply to be 144, but add to be 25? And that's a 9 and a 16. So in this case here, we have 9 and 16. 9 times 16 equals 144. And 9 plus 16 is a 25. The longer sides are N here, so N is equal to 16 and M is equal to 9. So we have a 16 here and we have a value of 9 right there. Now, as we're going on even more, there's some more information that I can get. Notice here we have two side lengths of a right triangle. We have 16 and 12. Can we find the length of AF? And Pythagorean theorem can help us here. We have 16 squared plus a 12 squared is equal to an AF squared. Now we could solve this out, but hopefully you recognize that this is a 3-4 triangle, or 3-4-5 triangle. 3, 4, 5. Multiply everything by 4 here. 3 times 4 is 12, 4 times 4 is 16, and so 5 times 4 is a 20. And so AF is equal to 20. So we have the length of AF is equal to 20. Is there a way we can find the length of FC and then maybe add them together? Well, if we can find the length of FD here, right, we already know that FE is 12. We have two sides of a right triangle. We find a third length, again, Pythagorean theorem. And it's a 3, 4, 5 triangle as well because they're all similar here. Okay, so we have 9 squared plus a 12 squared is equal to that FD squared. 3, 4, 5 triangle, each one's multiplied by 3. 3 times 3 is 9, 4 times 3 is 12, 5 times 3 is a 15. So the length of FD here is a 15. And so can we apply 3, 4, 5 triangle again to find the length of FC? We only have one value. Which one is it? Notice in our triangles here, every value that's across from the beta is gonna be that 4 times our unit, the 3, 4, 5, the 4 times. So across from beta, we have our 4a value is equal to a 15, and across the alphas, our 3a value. So we have 4a, 3a, 5a, 5a being the hypotenuse. So if we figure out what a is, we can apply it then to times by 3 and get that length. So a is equal to 15 over a 4. Not too bad, divide both sides by 4. So 3 times a 15 over a 4 gives me that length of a FC, right there, which is equal to 3 times 15, 45 over a 4, which is equal to 11.25. If I remember correctly, correct, 11.25. That's the length of FC. So we can add it together. X is equal to AF plus FC, which is equal to 20 plus 11.25, which is equal to a 31.25. And again, that's our X value. X equals here, a 31.25. Did you get 31.25 as your answer? If you did, way to go, that's awesome. If not, well, hopefully you'll learn something here and I'll get a little smarter with geometry. So, as always here, thanks for watching.